We are on lesson 14. The problem number 1 says, Owen has a square sheet of paper that measures 1 foot on each side. He folds the paper vertically and horizontally that it makes equal sections. The model shows the unfolded paper. Which expression represents the area of one section? So I see that it's been folded this way and then this way. So I'm looking at 1, 2 would be my denominator, and then one of those sections would be right here. Then if I look this way, I see 1, 2, 3. So that would be my denominator, and just one of those would be like this. So I'm looking at 1/2 times 1/3, and I see that represented in letter C. Problem number 2. What is the area of a rectangle with a length of 7/5 meter and a width of 5/10 meters? So we're going to take 7/5 and we're going to multiply 5/10. So 7 times 5 gives me 35. 5 times 10 gives me 50. So I'm looking for 35/50 meters squared, or you could say squared meters, which is letter A. And then it says Patsy chose C as the correct answer, which is right here. How did she get that answer? So 12/15. Well, when I'm looking at 7/5 and 5/10 as my possible answer choices, and she's getting, I'm just going to put a question mark over here, 12/15, I'm seeing that she potentially added the numerators. So I'm going to write here, she added the numerators and then to get 15 as a denominator, it looks like she also added the denominators. Which is actually not what we do when we are adding fractions at all. We have to find a common denominator, and then we have to change our numerators to fit our new common denominator. So it looks like Patsy needs a little bit of help when she's working with her fractions. Problem number 3 says, each expression below shows the length and width of a rectangle in yards. Write the expression in the correct box according to the area it represents. So it looks like we're going to be taking each one of these areas, and then we're going to place them either here for less than 1 square yard. Here is going to be equal to 1 square yard. Over here is greater than 1 square yard. So I'm going to go ahead and multiply each one of these out and then place them where they need to be. So 2 times 3 is 6. 3 times 5 is 15. So this one's going to go right here. 2/3 times 3/5. 1 times 4 is 4. 4 times 1 is 4. And I know that 4/4 is the same thing as 1. So this one's going to right here. It's equal to 1 square yard. 1/4 times 4/1. So 2 times 5 equals 10. 3 times 3 equals 9. So already I can see when my numerator is larger than my denominator, it's greater than 1. So I'm putting it over here. 2/3 times 5/3. Then I have 1/4 times 5/3. 1 times 5 is 5. 4 times 3 is 12. So this one is less than 1. So 1/4 times 5/3. Then I have 1 times 9 is 9. 2 times 10 is 20. That's going to be less than 1 whole. Then my last one, 4 times 6 is 24. 3 times 8 is 24. I have 1 whole again. So I'm going to put that over here. problem number 4 says pick one of the expressions from problem 3 and draw an area model to represent the expression. So I'm going to choose 2/3 times 3/5, and you can choose whichever one you want. So I'm going to split it into thirds this way. And I'm going to color in 2 of them. So there's my first third. Here's my second third. And then I'm going to split it this way into fifths. One, 2, 3, 4, 5. And I need to shade in 3 of them. One, 2, 3. So now we're going to see how many of these parts have both green and purple. 1, 2, 3, 4, 5, 6. So I have 6 out of, we've already counted our 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So up here we did the standard algorithm, just multiplying our numerators, multiplying our denominators. Down here we did a model for it, and we got the same product. Number 5 says write an equation to show the area of the rectangle in problem number 4. So here we have our rectangle. So our problem is 2/3, and remember this is just standard algorithm for multiplying fractions, times 3/5. And so what that looks like is our numerators are getting multiplied. So 2 times 3, which gives us 6. Our denominators are 3 times 5, which is 15. So we've done that 3 times now. This is what it looks like doing standard algorithm. This is what it looks like when you have a model.